lunar oceans that may house alien life, strange magnetic field changes scientists weren't expecting to see, and the discovery of active volcanoes on distant moons. These are amazing discoveries Voyager made at the edge of our solar system. Voyager 1 and 2 are space probes launched by NASA in 1977. After they flew past Neptune in 1989, their mission wasn't over. The spacecraft kept traveling beyond the planets, pushing further and further into our solar system. In 2012, Voyager 1 crossed into interstellar space, and Voyager 2 followed in 2018. This was a huge achievement because these were the first spacecraft to venture so far from Earth. Now, interstellar space isn't what most people think of as empty. It's actually filled with particles, atoms, molecules, and dust. As Voyager moved into this region, it faced some new challenges. One big one is cosmic rays. These are high-energy particles traveling nearly at the speed of light. As Jamie Rankin, a space physicist at Princeton, explained, on Earth, galactic cosmic rays are heavily shielded by the sun, but there are a lot more of those out there where the Voyagers are, end quote. These rays are dangerous because they could hit Voyager's electronics and fry them. Luckily, Voyager's computers are old, and that actually works in its favor. They're much larger than modern tech, so they're able to handle these cosmic rays a lot better. Even though Voyager 1 and 2 are far from home, they've still been sending back valuable data that we're going to be sharing with you today. Voyager made a groundbreaking discovery when it found evidence that two moons in the outer solar system, Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, could have oceans beneath their icy surfaces. According to Carolyn Porco, a planetary scientist, it, quote, set the stage for the discovery that these worlds actually have liquid water oceans under their surfaces. These discoveries were crucial in guiding future missions to these moons. Cassini, a robotic spacecraft which explored Saturn and its moons, later found hydrothermal vents on Enceladus in 2017. And here's something really cool. Scientists think that these could be signs that life may exist there. According to American planetary scientist Linda Spilker, because thermal vents on Earth can have colonies of life, we wonder, perhaps, if there's also life in the oceans of these worlds. We will learn more in the near future. In 2024, NASA launched the Europa Clipper spacecraft to Europa to gather more data, but it won't land until April of 2030, so don't hold your breath. As I said at the top, as Voyager entered interstellar space, it started recording measurements that nobody had anticipated. One of the most surprising discoveries was the sudden spike in plasma density and magnetic field strength. Plasma is a state of matter made up of charged particles, and Voyager's instruments started to detect an increase in its density. Don Kurth, a member of the Voyager science team, said that the measurements, quote, suggest Voyager is exploring an unknown region of space, going on to explain that while scientists had expected the transition from solar wind to interstellar wind to be smooth, the data from Voyager pointed to something different, something more complex. Solar wind is the flow of charged particles from the sun that fills the solar system. It creates a sort of bubble around the sun called the heliosphere, and this stream of particles is what Earth and other planets experience all the time. But once you move past the outer edges of this bubble, things start to change. The spacecraft's data showed spikes in plasma density and shifts in magnetic fields, meaning Voyager was encountering something new. Instead of a clear transition, it was moving into a region where interstellar medium, the material that exists between stars, was mixing with the solar wind. The interstellar medium is made of gases and tiny particles, but it's much thinner than the solar wind, so this mix of solar wind and interstellar material created a more complex environment than scientists had expected. In 1979, Voyager 1 made a groundbreaking discovery when it passed Jupiter and its moons. The spacecraft provided the first ever close-up images of Io, one of Jupiter's largest moons. To scientists' surprise, these images revealed that Io was not a quiet, frozen moon like many others in the solar system. Instead, it was incredibly active. Voyager captured images of volcanic eruptions, with plumes of gas and molten lava shooting up into the sky, but the volcanoes on Io aren't like the ones we have here at home. They don't erupt with lava flows and ash clouds as much. Instead, they're mostly made up of sulfur and sulfur dioxide, and some of these volcanoes are so powerful that they shoot material all the way up into space. The images showed a surface covered in lava lakes and volcanic pits. This was a big discovery because, unlike most moons, Io wasn't just a cold, dead rock. It had heat inside and was and is still changing. This is mostly because of Jupiter's huge gravity, which pulls on Io as it orbits. That constant squeezing and stretching creates enough heat to fuel its volcanoes. Voyager 1 and 2 also learned something else about Jupiter, that it actually has rings. Sure, that's common knowledge now, but before the Voyagers showed up, Jupiter's rings were completely unknown. The Voyager probes discovered that the planet's ring system was faint and made up of small particles, much smaller than the ones that make up Saturn's more famous rings. Jupiter's rings are composed mostly of dust particles. They're much harder to see than Saturn's, which is why they hadn't been noticed by telescopes before. Jupiter's rings were confirmed to have three main components. There's a thin inner ring made up of dark particles that reflect light, and then there's two outer rings, which are made up of more diffuse dust particles. When Voyager 2 flew past Uranus in 1986, one of the spacecraft's biggest discoveries had to do with the planet's magnetic field. It found that Uranus's magnetic field wasn't like any other planet in the solar system, including Earth's. Instead of being aligned with the planet's axis of rotation like Earth's field, Uranus's magnetic field is tilted at an angle of 59 degrees to its rotation axis. This means that Uranus's magnetic field is extremely unusual. It creates a highly unpredictable environment for the planet's magnetosphere. A magnetosphere is the region around a planet controlled by its magnetic field, protecting it from stuff like solar radiation. Voyager 2's data also showed that the magnetic field of Uranus is also off-center. It doesn't originate from the planet's core. Instead, it comes from a spot deeper inside the planet. It seems that the planet's interior was a lot more complex than scientists had thought before. The magnetic field is also asymmetric, meaning that the planet's two hemispheres have vastly different magnetic properties. Understanding how Uranus's magnetic field operates also gave scientists some clues as to how other planets, like Neptune, might generate their own magnetic fields. In 1989, Voyager 2 made a pretty cool discovery as it flew by Neptune. The spacecraft's instruments showed an enormous storm system on the planet's surface, which was later named the Great Dark Spot. This storm, similar in appearance to Jupiter's Great Red Spot, was a dark, circular cloud system that was swirling in Neptune's atmosphere, and it was massive, about the same size as Earth. It was a raging storm with high-speed winds and a very deep dark blue color. The discovery was pretty fascinating because it showed that Neptune, a planet so far from the Sun, had weather systems that were incredibly active. This storm system helped confirm that Neptune's atmosphere was not just a calm, cold environment, but a place with complex weather patterns that could even rival those on Earth. But when astronomers took a look at Neptune again in the 90s with the Hubble Space Telescope, the Great Dark Spot had disappeared. Voyager 1 and 2 also helped discover several new moons orbiting Jupiter. Before the Voyager missions, Jupiter had only been known to have a handful of moons, but during their journeys, the spacecraft discovered three previously unknown moons that were orbiting very close to the planet. These moons were later named Adraste, Metis, and Thebe. Adraste is the smallest of the three and orbits just above Jupiter's inner ring. Metis is found just inside the orbit of Adraste and is slightly larger. Thebe, on the other hand, is farther from Jupiter and is shaped more irregularly than the other two moons. The fact that these moons orbit so close to the planet might mean they were captured by Jupiter's strong gravity rather than formed by the planet's own disk. And the more we learn about how things like moons form, the further we're able to get an understanding of the history and evolution of our solar system, and maybe even how planets and moons form in other systems. One of the most exciting discoveries made by Voyager 1 was the detection of an atmosphere around Saturn's moon Titan. Titan is the second largest moon in the solar system, and what made it especially interesting to scientists was the discovery that it has a thick atmosphere, unlike any other moon in the solar system. Voyager 1, during its flyby of Saturn in 1980, discovered that Titan's atmosphere is mostly composed of nitrogen, with traces of methane and other gases. The atmosphere was very dense, even more than Earth's, which raised a lot of questions about what was happening on Titan's surface. Scientists knew that Titan was too cold for liquid water to exist, but the thick atmosphere and the presence of methane could mean that there are other forms of chemistry at play here. The mix of nitrogen and methane could mean that the conditions on Titan might be similar to what Earth had before life began. This discovery set the stage for future missions, including the Cassini-Huygens mission, which would later land a probe on Titan's surface in 2005. It also got scientists talking about the idea that Titan could potentially host some form of life, though very different from anything seen on Earth. One of the most remarkable things about the Voyager craft is how long they've been operating. Launched in 1977, the spacecraft were never meant to last this long. In fact, they were only designed to operate for about 5 years. But despite being nearly 50 years old, both Voyagers are still sending back valuable data from over 15 billion miles away from Earth. The technology aboard the Voyagers was cutting edge in the 70s, but by today's standards, it's incredibly outdated. But this old technology has actually worked in their favor. Again, the spacecraft were built with bulky, durable materials, so they're better at withstanding damage from the harsh environment of space compared to newer, more delicate technology. Alan Cummings, not the actor, a physicist and longtime member of the Voyager team, pointed out that the spacecraft's larger and more rugged systems are better equipped to survive the intense radiation of interstellar space. So they're still kicking, but they won't last forever. Eventually, they'll stop sending data and will disappear into the vast reaches of space, lost like tears in rain. But even when that happens, we'll still have all the valuable data they were able to provide. So raise your glasses to Voyager 1 and 2, and I've been your host, James, and I'll catch you next time.